Hey there and welcome back to the C# for Total Noobs training. This time I guess we'll have a very interesting lesson because we'll first of all talk about stacks, which is another type of collection that we have in C#, but that's actually more general. The concept of stack is, I would say, actually or virtually the same among all the programming languages. It is actually a very basic data structure that we use in programming, so we have to take a look into what stacks are and how stacks work. And due to the fact that stacks, have some very specific characteristics, they are suitable for certain scenarios when we are building our apps. And I thought that we could already build a first very simple but really workable app using stacks. So in the part where we will do the demo, we'll also create an app today where we will implement the stacks and we'll see how useful they might be in certain scenarios. So let's get started with it. First of all, stacks, as said, are collections. But if we compare them to lists, they have some very specific characteristic. Now, the main characteristic of the collection that they can shrink or grow the size dynamically is still true for the stacks, but with a certain catch. Stacks are a very nice data structure that is also called a last in, first out or LIFO data structure, which means that whenever we add something to the stack, we actually add it on top of the previous element. So you can actually think about a stack really like a stack of books that you might have on the desk. And when you add another book to the stack, you add it directly on top of it. So this is why when we think about stacks and how their sizes may grow or shrink dynamically, we always have to think about adding or removing items from the top of the stack. That's why this concept of the top of the stack is very, very important. So this means that whenever we actually want to grow the stack, when we add or push a new element to it, it will actually be pushed on top of the stack. And when we want to pop out an element or take an element out, it will take the first element or the first element in the top of the stack. So if we push this element right here, right now, when we want to pop an element, this same element will be popped. Now, this means that if we want to arrive, let's say, at this element here, or at the really first element in the stack, so the one that is really the first down, we would have to pop first this one, then the other one, and then the other one, and we finally arrive at this one. So we cannot access directly this first element that was ever pushed to the stack. So this is the very common characteristics. And of course, when it comes to C# and .NET, then we have methods on the stack class that help us to achieve exactly this type of behavior. So when we want to grow the stack, we add something on the top. And when we want to shrink the stack and take something out, it will always be the element that it is on the top of the stack. And this is why, this is the main characteristic of a stack data structure. And for instance, this type of behavior is actually very common and very important. For instance, if you're building an app and you want to build in that app an undo and redo functionality, like you have in Word, and almost in all apps, you have the option to undo something that you have done previously. So this means that you actually basically put a lot of actions on the stack, so what user does, and when you want to undo, you just pop the last one and it should remain the state that it was previously. So that's actually how this is supposed to work. Or in browser, for instance, where you have this back and forward button. Here, this is one other scenario where implementing such a behavior using stacks is the way that we could probably do that. So this is why stacks are very, very important, and it's really nice to know these characteristics about stacks. Now let's go over to Visual Studio and play around with some stacks and to see this functionality. So we are here in the same solution that we have used previously for the list demo. So let's here just add a new class. Where is it? Here, class. And we'll call this class this time stack demo. And that should do it. And we'll do exactly like we did for the list. Let's make this public. And let's create here a static method run. Public static void run demo. So exactly like we had in the list. And then in the program.cs, we can just simply comment the run demo from the list demo, and we add here the stack demo, put run demo, and that should do it. So now, right now, we should print in the console and do everything that we actually want to do here. So as said, here, for instance, when we use stacks, we can have a stack of string. We start from an example that we used also for the list with the cities. So let's call this cities, and this would be a new stack of string. Now, since the stack is actually a very specific type of collection with a very specific behavior, as we have seen, so you can just push things to the stack if you want to add something and pop elements out of the stack if you want to retrieve them. So it means that here we won't use any collection initializers. So if we want to push things to the stack, we can then simply just use the push method on the stack. And here, of course, since this is a stack of string, and we have discussed about this idea of generics and why we have this data type here. So if you haven't followed the previous video on lists and generally about collections, then please pause this one and go to the previous part where we explain this deeply. So let's add some cities here. So it would be for Seattle cities dot push. Let's add another one. Let's add, like we did also the previous time, Munich. Let's add a new one, cities dot push. Let's add in this time this one, and last but not least, let's push another city to the stack, and that would be Timisoara. Okay, so now we have a fully functional stack. Now, what we can do here to kind of demonstrate the behaviors that we have on the stack, and I will then also get some code and paste it. But once again, if you're watching this and if you are at the beginning stages of your C# learning, then please pause this video and type this by yourself. It's very, very important that you get accustomed with typing code. So what we actually do here, we do a bunch of console write lines, of course, but this is actually not important. The important part is that I want to show you the functionalities that we have on the stacks. So here we see that we can also get the current number of elements with the count property. This is something that's specific for really all collections, which is fair enough. But what I wanted to show you here is this peek method and this pop method, because we have seen push. With push, we just push new elements on top of that stack. Now, the pop method, as said, they just actually take out the element that is on the top of the stack. So the element is really taken totally out from the stack. It's not there anymore. But this peek method, that's a very interesting one, because there are times where you might want to find out which is current or what is currently the element on top of the stack. But you don't want to take it out, you just want to find out what the element is. So in that case, you can use this peek method. So the peek method will return you the element that it is right now on top of the stack, but without removing it from the top of the stack. So the idea here is that we have a count. So when we run this for the first time, we should have 4. And then when we use the peek method, we will be able to see which is the element on top of the stack. But when we do, once again, the count will be exactly the same, because the peek method doesn't remove it from the stack. It just tells you which is the last or the first element or the element on top of the stack. And then we use this pop method, which actually retrieves the element, but also removes it from the top of the stack. So it's not there anymore in the stack. So afterwards, when we use this count property, then we should have only 3, because 1 was totally taken out. So it was totally removed from the stack. So let's run the application and see exactly what this actually means. So we have here number of cities in the stacks, which is 4. Then we use the peek method and we retrieve which is currently the element on top of the stack. And then when we do the count, it is still 4. Because once again, the peek method just tells you which is the last element, but it leaves it actually there on top of the stack. So it doesn't remove it. But then we use the pop method. Of course, the element that was retrieved was exactly the same because that was the element on top of the stack on the stack at that point in time. But then when we do the count, we see that we have only 3. And this is once again because the pop method, it returns you the element, but it also removes it from the top of the stack. So in this case, the stack right now doesn't have 4 elements anymore, but it actually has only 3. So that's actually really the basic or the fundamental functionality of stacks that we have here. Now, one other thing that we can do is, of course, use a for each or a for loop, or in this case, a for each, I guess, to go through all elements in the stack and then write them in the console. That's something that we can do on all the collection or on all the collections. But let's see exactly when we did this for each. The order in which we actually receive the elements is actually very important. Because you see that when we did push something to the stack, it was Seattle, and then Munich, and then a Lisbon, and then Timisoara. So this means that the current stack is from bottom to top. So Timisoara is the first element in the stack, Lisbon is the second, Munich is the third, and Seattle is the fourth, and currently also the top of the stack. Now, of course, we have removed the element that was on the top of the stack, which was, of course, Timisoara. So in this case, we see that, well, we actually get the for each. It actually prints us exactly in the order in which we have the stack. So Seattle here is on the bottom, Munich here is then the second, and Lisbon here is on the first line actually. So yeah, this is a very interesting thing to note, and well, I would say very specific characteristic once again of the stack when you loop with a for each loop and try to get each element of the stack. It actually it actually maintains, let's say, the order that you would have normally in a stack. So this is the bottom and this is the top, and with the for each we start with the top of the stack, which is actually what we expect. Okay, so as said, this is the basic functionality of stacks in C#, so it's not very complicated. But what I want you to do right now is to kind of like build a very small application with you. And this application is very simple, but very powerful in order to display the scenarios where stacks might be useful. And it would be a simple undo and redo functionality in our console. So what this actually means is that when we start our console, for instance, let's run the application. So now it won't really be the case, but for instance, we can start typing things. And what we want to do with our application is to have the ability, for instance, if we press the left arrow on the keyboard, to make an undo. So it would actually remove the D letter and it should print all the string, but without the D. If we press again the left arrow, then the S should be removed. If we press again, then the A should be removed, and things like that. But when we press the right arrow, then the A should come back. And if we press it again, then the S should come back. And if we press it again, then D should come back. So this is a very simple undo and redo functionality using the left arrow and the right arrow on the keyboard to undo and redo characters that we have written actually in our console. So this is the main concept of the application that we want to build. And since this is an application, I would like to also have a new class for it. And let's add, on the project, add a new class. And we'll call this class UndoRedo app. Let's make it public. So what I want to have here is a public method. It shouldn't be static because I want to create an instance of UndoRedo app before we can run it. And here we can simply call this run. And here's all the place where we'll implement the logic. Now in the program.cs file, we will comment out this stack demo, and instead what we'll do is var app equals new UndoRedo app, and then we'll have app.run, and this will actually run our application and execute all the code that we have in our run method. So let's go back here to this undo and redo app. Now, the main concept of how we will or how we want to implement this is that we actually want to use two different stacks. One of the stacks is, or we can call it something like the main stack. So whenever we press a button, a certain character on the keyboard, we want to actually put it in that specific stack. Now, when we want to print it, we will actually transform the stack into an array, because then we can easier loop through it. And then we display, we clear all the contents of the console, and we actually redo all the contents, or we will display all the contents from the stack from scratch. And when we hit left arrow, we just take or pop something or the last element from the main stack and put it in another stack, which we will call something like undo stack. And if we press once again the left arrow, we will do exactly the same thing. So we will pop the last element from the main stack and push it actually in the undo stack. Now, when we press the right key, it will happen exactly the other way around. We'll pop out from the undo stack and we'll actually push back onto the main stack. And after each such operation, of course, we will print the main stack in the console. So let's try to implement this. So we'll have a stack of string, of course, or actually it's of char, because we will be working with characters here. So it's a let's call it main stack, the first one, and it would be a new stack of string. Sorry, not here, but here. Okay, and then let's see what stack of chars. Sorry, because we are using chars. Yeah, this time it's okay. So, and then we have another stack of char, and that would be the undo stack. And this would be another new stack of char. Good. So we have this set up. Now, another thing that we want to have is we need to keep the console open and listen actually to the keys that are pressed in that console. So in this case, we'll have also a variable. Let's call it run program, and we'll set this to true right now. And we'll use a while, and we'll say that while run program. So while this is true, then we want to do all the stuff that we need. So what do we need to do? First, we need to check what key was pressed. Then we have to take some decisions, and we have basically three scenarios. If a regular key was pressed, then we just push it to the main stack. If the left arrow was pressed, then we just pop from the main stack and push onto the undo stack, and then print the current main stack after we have removed the top element of the stack. If we press the right key, then we do exactly the inverse operation. We pop something out from the undo stack, push it onto the main stack, then print the main stack. And these are basically the three scenarios that we will have. So the first thing is we need to listen to what key actually was pressed. And in this case, we have on console, we have this read key method. And here we have to provide also a false, because the read key has an option to also print on the console the key that was actually pressed. And if we would set this to true, then it would actually do that, but we don't want to do that. We just want to listen to what key was pressed, and then we can access it via this key property. Now, there is one catch here, and of course, as I said, this, or the purpose of this app, is actually to show you how we can work with stacks and to demonstrate a scenario in which a stack would be possible. Now, for sure, we will probably never implement this type of undo and redo in a console application. And that's why I don't bother of different subtleties. But the main subtlety here is that the read key method and the key property will always return, or will always return the pressed character as an uppercase character. So this means that if even if we press a lowercase a, here actually this key would be an uppercase a. So this means that we will only support to lower, so we will make everything to lower when we display in the console. So when we read this key, so after we have read this key, as I said, we have three different scenarios that we could implement starting from that. And in this case, we could of course use a switch statement. Seems quite right in this case. So, and I would like to do a switch on key. And here Visual Studio just wanted to just implemented this for me, and I really didn't want it to do. So let's delete everything, and we'll implement only what we need, because it implemented all the possible keys that we have on the keyboard right now. But we actually don't care for all the others. We are just interested in characters, and if it is a left arrow or right arrow. So okay, sorry for that. So the first one is case, and here we see console key, or let's start with the default. So in the default, what we actually want to do, as said, when we are in the default, so it was no left key and not the right arrow. In this case, we just want to push the key as a character on the main stack. So we will have the main stack dot push, and we will have to cast the key to a char. So char key. And we have a separate lesson on boxing and unboxing and casting. So if you're not familiar with this, then just please pause this video and go and look at that video, which is, I guess, on called, or it is the part where we talk about boxing and unboxing. We also talk about casting. So yeah, so this is, we actually take the key, we cast it, or we transform it to a char, and we push it to the main stack. Now let's take the other cases. So if we have the console key dot left arrow, so this is where we actually want to implement our undo functionality. And as said, in this case, we just want to push in the undo stack the last element of the main stacks, and we can simply use the main stack dot pop. And that's basically it, and then we can clear the console. So it's console clear. Okay, that should do it. And now what we would have to do is actually to print the main stack here on the console. And to do that, we will transform it to an array. Let's see what we have here. So I have copy pasted this, and where we have this array to print, and in this case we have the main stack that we want to transform to an array. And now the important thing here is, because we have seen when we did a for each on the stack demo, it actually gets, when we transform it to array, it actually gets all the elements in the order that we actually don't need. So it actually starts with the top of the stack, but we actually need, when we want to actually reprint the existing string without the last character, we actually want to start from the beginning. And when we transform this to array, the beginning of the stack will actually be at the end of the array. So this is why we start with I at length -1, and we use an I minus, so we decrement I. And then of course we print the current element in the array, and that should do it. Now this is the case for the left arrow. Then let's add another case console key dot right arrow, and in this case, well, we actually want to do something very, very similar, but the main difference here is that what I want to do is that I want to main stack dot push undo stack.pop. So you see, it's exactly the reverse operation to the other scenario. And of course, then we can also have a break here. And then we also want to clear the console. And of course, then we would also like to print. And you see that what we would do here is, well, I would be tempted to just take this from here because it's exactly the same operation, and I would like to use it here. Now, of course, since we are here in a switch and case statement and we are inside the same code block, actually we get here this red squiggly line which indicates that we have an error. And if we look at it, you see that a local variable or function named array2print is already defined. So yeah, this means that, this is already defined. So I can't define it anymore. Now, one thing that I could do is, okay, then it is already defined. I don't define it anymore. I just use it. But that would solve my problem. So you see that we don't have any red squiggly lines anymore here. But in this case, we can see that, okay, this code here and this code here is exactly the same. And it's also conceptually doing exactly the same thing, print something to the console. So this is the perfect scenario where we see, hey, this is a code smell. We have code duplication. That's not good. So whenever you see duplicated code, it should be a red flag for you. Something is not okay. You should refactor. And how can we refactor this in order to be, well, a well-engineered application? Well, we can extract this functionality of printing something to the console into a separate method, which of course, this is a method that should be known only by the UndoRedo app class. So we'll make it private because only this class should know this method and how to work with it. And it would be a private void. It won't be static. We don't need actually a static one. And here we will have a print, let's call this print stack. So the purpose of this method is just, hey, I'll give you a stack to print, a stack of characters. So a stack of char, let's call it stack to print. And yeah, this means that we can simply move this functionality here from here in this stack, in this new method. So we will do this like this way. And here it would be stack print. Okay, so that's very, very cool. We extracted this functionality, so we don't need to duplicate code anymore. So instead of doing this after we clear the console, we just use the print stack and provide the main stack, because we always print the main stack in this case. And if the console key is the right arrow, we do exactly the same. We can just reuse the method print stack. So we have done this, and we also want the main stack to be used. Okay, and I guess our app should be ready for testing right now. So I don't see any errors, and conceptually we should have all the functionality here. So let's run the application and see exactly. Let's start writing. Hello world is the first app we write. Now let's press the left arrow. And you see that, well, everything is now lowercase, but the E is not there anymore. Let's press the left arrow again, and it's the same. So we see that it's actually undoing everything we have written. Is the first app, and here maybe developers create. So that's cool. We have written something else. Now, if we want, once again, we can simply just press undo as many times as we want, and then we can also press redo, and everything will be fine. So you see that we are constantly pressing the undo and the redo key, and everything is working fine. Now we just need a way also to exit this application, so we'll just add a new case here, and the new case console key, and sorry, console key dot escape. So if we press escape, in this case, we just want to set run program equals false. And theoretically, if we press escape, we should then actually, and we need a break, of course. So when we press the escape key, then actually our program should quit. So this is the quit functionality. So let's run it again. Let's start typing something. Let's do some undo. Let's do some redo. And then let's press escape. And unfortunately, nothing happened here. I'm not sure exactly why, but I guess you get the idea. Maybe we didn't enter this, but let's debug this and see exactly what happens. So we have here, let's start. Okay, yeah, right now I wanted to, let's press continue. And let's press escape right now. So the key, we see that it is escape. Now we set run program to false. And here run program equals false. And we just exit here, but the console remains open. So actually it worked, because yeah, in that case we should just close the console. It worked because if, for instance, we press escape, in this case, undo and redo will not work anymore. Let's take out this breakpoint. Let's press escape. And right now I'm pressing left arrow and the application is not working anymore because we have actually set this run program to false. But in this case, I'm not sure exactly. As say console dot, it's just clear. So yeah, we can just close the console right now. Probably we'll have to stop it somehow. But the idea is that well, we stop executing our app. If we press escape, you can't actually undo and redo anymore, which is actually, I guess, what we wanted. So once again, this is a very basic example of a certain scenario and functionality where working with stacks might be useful, and understanding how stacks work would probably help you out if you are in scenarios that are very, very similar to what we have implemented right here. So this being said, thank you very much for watching this lesson, and until the next time, I wish you the very best.